Hi everyone, it's Mrs. Martello. We're going to look at section 1.3 and we're looking at solving equations with variables on both sides. If you want to follow along with me, I'm using the textbook. You can use the online textbook. I'm on page 20. So we're going to take a look here. Before we start going over individual questions, let's talk about the steps we want to take. I encourage you to pause this video and copy these notes down so that you can have them for reference. The first step whenever you're solving any equation is you want to simplify each side of the equation, each side of the equal sign. If you can distribute, you want to do that. If you can combine your like terms, you want to do that. Our next step is we want to get the variables on the same side. So if there are variables on both sides of the equation, let's get the variables on the same side of the equation. I think that's the best way to approach it when you solve equations with variables on both sides is work with the variables first, getting them together, and then you just have to isolate that one variable. So now let's start focusing on isolating the variable. We're going to eliminate the constant term, which is the number being added or subtracted. We're using the inverse operation to cancel it out. And then we'll eliminate the coefficient, which is the number in front of the variable, whatever is being multiplied or divided with the variable, again by using the inverse operation. So I'm going to look at example 1. I already wrote down the example on my piece of paper here. If you want to follow along, please write down the equation. 10 minus 4x equals negative 9x. So our first step is to see if we can simplify. On the left side, no, nothing can be simplified. On the right side, nothing can be simplified. So this is already simplified. We're going to go to step 2. Let's get the variables on the same side. So when we do this, in this question, because there's only one constant term on the left here, we're going to focus on leaving this constant term where it is and moving the variable, this negative 4x, to the right side so that all the variables are on the right and all the constants are on the left. So because this says minus 4x, we're going to do the inverse and we're going to add 4x to both sides. Now we're left with 10 equals negative 5x. Our step now is we're going to start to isolate this variable here. Our next step would be to eliminate the constant term with the variable, but there is no constant term. Nothing is being added or subtracted, so I can skip that step. Now let's eliminate the coefficient, which is negative 5, the number being multiplied in front of the variable, and we're going to use division. So we're going to divide both sides by negative 5, and we get negative 2 equals x. Let's check our answer just to make sure that this is correct. I'm going to take my answer and plug it into the original equation for both of these x's. So we have 10 minus 4 times negative 2 equals negative 9 times negative 2. Let's simplify. So this would be 10. This is a negative 4 technically, and a negative 2 gives me positive 8. Equals negative 9 times negative 2, that would be positive 18. When I add these together, I do get 18 equals 18, so I know I got the answer correct. Okay, let's take a look at our next example, which is example 2. Okay, in example 2, now we're going to solve the equation. Again, it has variables on both sides, and we have grouping symbols. So now we're kind of putting everything together here. We want to simplify as much as we can. Let me write down this example's equation. 3 times the quantity of 3x minus 4 equals 1/4 times the quantity of 32x plus 56. All right, let's solve for x here. So first we're going to simplify each side. On the left side, I'm going to distribute the 3, and on the right side, I'm going to distribute the 1/4. When we're distributing, remember we're multiplying. 3 times 3x is 9x. 3 times negative 4 would be minus 12. Let's multiply on the right side. 1/4 times 32x. When you're multiplying by 1/4, it's the same thing as dividing by 4. So this would be 8x plus 1/4 times 56. Again, you're dividing by 4. So that would be 14. All right, so now we simplified everything. No like terms on the left, no like terms on the right. Let's start getting the variables on the same side. So if you notice up here, I mentioned that when you get the variables on the same side, it's best to try to eliminate the smaller variable. And that makes sense here in example 2. It did not work in example 1 because there was only one constant. But in example 2, when there are two constants and two variables, think about what makes more sense. Does it make more sense to move the 8x to the left, or does it make more sense to move the 9x to the right? Well, if I focused on the 8x, I would subtract 8x and I would be left with a positive 1x over here. If I wanted to move the 9x, I would minus 9x from both sides and I would be left with a negative 1x over here. I don't know about you guys, but I prefer positive numbers over negative numbers any day. So I'm gonna try to make sure that I deal with positives by eliminating the smaller variable. Since 8x is smaller than 9x, let's eliminate this 8x. We're gonna subtract 8x from both sides. And notice when I do this how I line it up underneath the like term. 9x and 8x are like terms. Let's subtract them. I'm left with 1x, or I could just say x, minus 12 equals, I just have 14 over here on the right. Now let's start to isolate the x here. We're gonna add 12 to both sides. I don't really need to write this 1 in front of the x, so let's just say x equals, or add these together, 26, and now I am done with this equation, and that is my answer, x equals 26. Okay, if I wanted to check my work, I could plug it into the original equation like how I did before. I could do it in my head, I could use my calculator to do it, and that's totally up to you. You decide however you want to do it. Let's do it in our calculator just to double check. So here I'm using my graphing calculator. I have an older version. This is my calculator from high school. It's a TI-83. The newer versions are 84s. You don't have to have a graphing calculator right now. There is an online version of a graphing calculator too, so I wouldn't worry about going out buying one. Any calculator is fine, but I just want to show you that we're going to get this answer to check out. So I'm going to do the left side first. 3 times 3, and then let's plug in our 26 times 26, and then minus 4, and then close your parentheses. We get 222. Let's try the right side. We're gonna have 1/4 times 32 times 26 plus 56, and we get 222. So we know that it does work out because both sides equal 222. Okay, let's keep on going. We're gonna next talk about special solutions. So I'm gonna write down some notes down here about special solutions. Special solutions occur when all the variables cancel out. When all the variables cancel out and there are no variables left in the equation, that means that it's called an identity. It's called an identity. There are two kinds of identities, and we'll talk about both of these identities here. The first kind of identity is when the result is true. If the result is true, that means that the solution is that there are infinitely many solutions. Infinitely many solutions. Now we can use an abbreviation for this, infinitely many solutions. We can say IMS. It's just a little bit shorter so we don't have to write it all out. But that's if the result is true. So for example, all the variables cancel out and we're left with like 1 equals 1. Well, that's true. So that means that there are infinitely many solutions, which means that our variable can be any number. Any number we want, we could plug it in and it would be true. If the result is false, that means that it can't work, which means there is no solution to that problem. There is a symbol that stands for no solution that you're welcome to use. It is a circle with a slash through it. Technically, this symbol means empty set, which means the set of the solutions is empty, so there are no solutions. We're going to look at some examples that follow along with these special solutions. This goes from example 3. So I'm going to take a look here at example 3. part A, let's write down the equation here. We're going to work through it together. 3 times the quantity of 5x plus 2 equals 15x. Let's solve this equation. Our first step is let's distribute the 3. We get 15x plus 2 equals 15x. So right away you can kind of notice that something interesting is going to happen. When I go to get these variables on the same side, let's go ahead and subtract 15x from both sides and look at what happens. These 15x's cancel out. I'm just left with 2 equals. These 15x's cancel out as well, which means this would be 0 on the right side. All the variables canceled out, which means that this is going to be a special solution. Now I just need to decide what identity is it. Since 2 does not equal 0, this is false. That means that there is no solution to this problem. We can also use the symbol for no solution as well. And what this means is that there is no number I can ever find for x that I could plug in for both of these x's that would ever make this equation equal. Let's look at example B here, 3b. Negative 2 times the quantity of 4y plus 1 equals negative 8y minus 2. Let's solve this equation. We're going to start by distributing. We get negative 8y minus 2 equals negative 8y minus 2. And again, you should notice that something funny is happening here. Let's get the variables on the same side. I would add 8y to both sides to cancel this out. And look at what happens when I add 8y to this side as well. It cancels out over here. So I'm left with negative 2 equals negative 2. Since this is true, that means that there are infinitely many solutions. Or we can also just say IMS. And what this means is that I can pick any number that I want in the entire world and plug it in for both of these y's, and it would make this equation true. So there are infinite numbers in the world, which means every single number would make this equation true. Okay, we're going to take a look at a word problem here, and we're looking in the exercises for this word problem. So I am now in the 1.3 exercises. I'm on page 23. And again, we're looking at word problem, and we're writing an equation. So in this word problem here, in number 18, lucky for us, they already gave us the equation that's here. We're going to try to ignore this equation and see if we can come up with our own equation based on the situation here. So I'm going to cover this up, and let's pretend it's not here, and we're going to practice writing our own equation because they're not always going to give it to us. So it says we're going to write an equation. It's going to represent the number R of movies you must rent to spend the same amount at each movie store. How many movies must you rent to spend the same amount at each movie store? Let's look at Movie World. All rentals are $1.50, and there is a membership fee of $15. At Video City, all rentals are $2.25, and there is no membership fee. Now, since I want them to cost the same, the idea is I want to set these two equal to each other. So we're basically going to say that Movie World, the cost, is going to equal Video City's cost. Okay, so let's come up with an equation. For Movie World, well, we have to pay $1.50 for each rental, and we're doing our movies. So it's going to be $1.50 per movie, so I'm going to multiply it times the number of movies, plus we have to pay this membership fee of $15. Now we're going to set this equal to Video City, which says it's $2.25 for each rental. So it's going to be $2.25 times the number of videos that we're going to rent. And this one does not have a membership fee, so this would technically be plus 0 for a membership, but we don't need to write plus 0. And there we have it. There's our equation, and I can double check that that is the equation that they gave us here. But now we practiced writing it without looking at it. And you are gonna have to be able to do this on your own. Okay, let's solve this equation. We're gonna get these variables on the same side. We're gonna minus 150r from both sides. We're left with 15 equals, we're gonna subtract here, this would be 0.75r. And we're gonna divide both sides by 0.75. If you wanna use your calculator, you can. If you don't wanna use your calculator, you can think about it in a different way. Remember that 0.75 is the same thing as 3/4. So if I wanted to solve this equation, I would multiply by the reciprocal of 3/4. So if I multiply this side by 4/3, it would get these to cancel out. And we can multiply this side by 4/3. Remember, this 15 is over 1. Let's multiply. So if I reduce diagonally here, 3 goes into 3 one time, 3 goes into 15 5 times, and now we can multiply. 4 times 5 would be 20. So this answer would be 20 equals r. So that would be our answer. Our answer would be r equals 20 rentals. And now you didn't have to do it that way. You could use your calculator, but I wanted to show you how you could do it without your calculator as well.